The least common multiple is looking at, if we look at multiples of a number. And first of all, what is a multiple of a number? Well, for 18, that's 18, and then 36, and then 54 is 18 times 3, then 18 times 4 is 72, and so on. And if we look at multiples of 30, well, 30 times 1 is 30, 30 times 2 is 60, 90, 120. And one way to find the least common multiple is just to keep writing them down until one appears to be the same. You just hope you don't make any mental math errors on the way. So if I keep doing this, if I add 18 again, oh, look at this. And you sort of can leapfrog until you get one that's the same. And so we would say that 90 is the least common multiple of 18 and 30. Yes?
Why would we ever go, what's the least common multiple of 18 and 30? Like,
where would we use that?
Yeah.
Okay, well, we have a word problem coming up where we could use an application of least common multiple. Okay? So, but it's a good question, but it's coming up. So method one, you could just write them out. And one way, when you're writing them out, once you see how I went to 72, and then I was like, okay, I'm going to start with my 30s. And once my 30s were past 72, I said, okay, I should go back to the other one. And you can sort of keep leapfrogging back and forth until they come out the same. Now, if you make an adding or subtracting mistake in here, you're going to run into a problem and find the wrong one. Method number two, you can use your prime factorization to do this as well. And so if we go back and review, well, what's 18? Well, 18 is 2 times 9, and 9 is 3 times 3. So 18 is equal to 2 times 3 times 3. And 30, well, 30 is 5 times 6, and 6 is 2 times 3, then 30 is 2 times 3 times 5. If we look here, and we look at the lowest common multiple, and the one thing I find interesting is there's sort of prime factorization, you do two things. You find the greatest common factor, which is always a number smaller than what you started with, even though it has the word greatest in it. And then you find your least common multiple or lowest common multiple, and it's always a bigger number than your greatest common factor. So that sometimes confuses people when they're trying to figure out which one they're supposed to find. But one of them, a factor is a number that's smaller than it. A multiple is numbers that are bigger. So with the least common multiple, using the prime factorization, what you do is you look at, was there any prime factors of 2? Yes. There's one here, one here. So in our least common multiple, we only need 1, 2. When we get to our 3s, was there a 3 that was a factor in either one? Yes. Which one had more 3s? The 18. So we will need both 3s as well.
So you write the number that's greater?
You always write whichever one. For the least common multiple, you take the factors and you take whichever one has the most. Do we have any other prime factors in either of these? Yes. We have a 5 in the 30. So we need to include 1 5 as well. So what's happening is you need to include all the factors. So once I include 1, 2 here, that accounts for the 2's. Once I include 1, 3 here, that accounts for 1, 3 and 1, 3. But I still need to add another 3 to count that second 3. And then finally, there's my 5. So if you like to check things off as you're going, that 5 shows me I've used up all of my prime factors. If I multiply this out in total, I get 90 as well. So we can either list all of our multiples until we get one that's the same, or we can find out the, we can find out the least common multiple there. One obvious place where you've used this before, okay? Because you have used least common multiple lots. Maybe you don't notice it, but if I wanted to add, okay, what were our numbers to start with? 30 and 18? Oh yeah, they're right there. If I wanted to add, what's 1/18 plus 1/30? What do I need to do? I need to find a common denominator. How do I find that common denominator? You could multiply them. Like I could multiply this by 30 and 30 and this one by 18 and 18, and I would get a common multiple. But if I find the least common multiple, this one needs to be multiplied by 3 and 3, and this one by 5 and 5, I'm working with smaller numbers. And chances are my fractions will be reduced easier. So this one becomes 5 over 90 plus 3 over 90 to get my final answer to be 8 over 90, which reduces to 4 over 45. So you use the least common multiple whenever you're adding and subtracting fractions, because to find your common denominator, and there's more than one common denominator, right? But the one that's the smallest is your least common multiple. And by making it the smallest, chances are your fraction in the end is close to simplified or closer to simplify. You would get the same answer if you made, if you times 18 by 30 and made a common denominator of 540, but then you're working with bigger numbers, and it might take you longer to simplify it. So there's something that you use all the time. You're going to add fractions from now till grade 12 a lot, trust me. And so you're going to need to find a common denominator, and the idea of least common multiple is built into that. A square patio is built using patio stones that measure 24 inches by 36 inches. How small of a square patio can you make if you're not allowed to cut the stones? So for example, this is 36, this is 24. Could I use one patio stone and make a square patio? No. It's not square if I just use one of them. So I take out a second one. I maybe should have not made this so big. And put it here. Is this a square now? No. Which side is longer? Up and down is now 48. So I'm like, oh, okay, I'll add one here and one here. So I'll make this another 36. Is this square now? No. What does the top add up to? The top adds up to 72. The bottom is 48. So my drawing is not that good, but if I had another 24 here, then 24 plus 24 plus 24 is 72. And 36 plus 36 is 72. And if I was a really good drawer, this would be a perfect square. Okay? So this is where you have to use your imagination just a little bit. Because apparently this is 72 and this is 72. It looks good to you? So the question was asking, what is the side length of the smallest square patio if the stones cannot be cut? The side length is 72 inches. What have we done in this word problem? This is the least common multiple. How did we find it? We used the technique of just adding along as we went and hoping we'd find it quickly. Okay? If this wasn't working well for us, what would be a really nasty stone length? Okay, I'm going to give you some nasty stones.
17 by 13.
No. 221 centimeters. These are big stones, by the way. Okay. 221 centimeters and by 77 centimeters. If your stone lengths were this, and you don't have to write this down, but I'm going to tell you that 221 is 13 times 17, and 77 is 7 times 11. That's our prime factorization. If we wanted to find our least common multiple or lowest common multiple of those numbers, what's our smallest prime number? 7. So we need to include it. Check. What's our next one? 11. Check. What's our next one? 13. Check. And finally, 17.
Does this work for any number?
This works for
Numbers? Does this work for
any two numbers. You can find out the least common multiple by finding out their prime factorization. Oh, I forgot to check this off. Okay, and if we multiplied this out, 7 times 11, calculators.
But you just timed the two numbers.
I did. In this
Why
case,
did you go through that process? Why not just time them?
because you don't know if that's going to be the smallest. You're right, I just times the two numbers, and I purposefully chose two numbers that would work. What's a pretty number? I like numbers that look like that. A little bit of symmetry.
But why go through the process?
Why go through the process? Because I could have given you, you want another example where it would be different? What about 221, okay? 221 and 220, should I do that one? No. No. There we go, that's pretty. Yeah. Yep, that's a good number. What times what is 221? 13 times 17, good. And 255, can you see that you could divide that by 5? 5 times 51. 51 is what times what? 3 times 17. So this is 3 times 5 times 17. What's the lowest common multiple here? Not just multiplying them together. Because now my lowest common multiple, what's the first factor I have to include? 3. Check it off. Then 5. Check it off. Then 13. Then check it off. And you only need 117 to check both of those off. So our least common multiple here is 3,315. Now, it's not very often that you would have to add fractions with a denominator of 1 over 221 plus 1 over 255 and want to find the lowest common multiple of 33,315, but this is an application of that. So when we read our questions, we have to figure out, is the question asking for the least common multiple, or is it asking for the greatest common factor? Sometimes it's obvious, like this one. Determine the greatest common factor. So you have to say to yourself, do I know what that means? Greatest common factor. The word factor means the things that multiply to equal it. And in most situations, we're going to use the prime factorization to figure it out. Two numbers that multiply to get you 180. 90 and 2. 2 is already a prime number. That one's done. Two numbers that multiply to give you 90. Want to do 3 and 30? 3 is already a prime number. Two numbers that multiply to give you 30. 3 and 10. Numbers that multiply to give you 10. 2 and 5. So 90, or 180, is equal to 2 times 2 times 3 times 3 times 5. $224. I'll do that in green. 224 is 2 times 112. And so if something is an even number, it's nice to just keep dividing it by 2. What's 112? 2 times 56. That, you can divide that by 2. 2 times 28. Can divide that by 2. 2 times 14. Can divide that by 2. 2 times 7. Until you get to all prime numbers. So we can write out that 224 is equal to 2 times 2 times 2 times 2 times 2 times 7. 1, 2, 3, 4, 5 2's times 7. So how do we use prime factorization to find the greatest common factor again? Well, do they have any 2's in common? Yes. They have 2 2's in common. How many 3's do they have in common? None. How many 5's do they have in common? None. How many 7's do they have in common? None. So after all that work, the biggest number that you can divide both of those by is 4. If you tried to list them all, it could be 1 and 180, 2 and 90, 3 and, listing them all, the factors, there's a good chance you'll miss one. And in this case in particular, I think you'd feel like it's got to be bigger than 4. I must have missed one. And you could spend hours checking your work. So having the prime factorization there is a really nice way to find greatest common factor. And if we wanted to find the lowest common multiple is where you have to include all of them. So I'd have to include all 5 2's, both 3's, the 5 and the 7. So here we have 3 numbers. You want to find the lowest common multiple of all 3 numbers. So again, we're going to start by finding the prime factorization. 28. If you can get ahead of me, that's perfect. It's 2 times 14. 14 is 2 times 7. So 28 is equal to 2 times 2 times 7. 42, 2 times 21. 21 is 3 times 7. Those are all prime numbers. So 42 is equal to 2 times 3 times 7. And finally, 63. 63 is what times what? 7 times 9. 7 is a prime number. 9 is 3 times 3. to find our least common multiple. We should probably find greatest common factor in this one after as well. The least common multiple of all of these. Do we have any 2's? Yes. If we include 1, 2, 1, 2 would check off 1, 2 there, and 1, 2 there. Do we need to include another 2? Yes. So we need to include another 2 to include that 2. Next, do we have any 3's? Yes, we have 3's. So if I include a 3, that would check off a 3 from there and a 3 from there. But I have another 3. Now I've used up all my 3's. 7. So even though there's a 7 in each one, we don't have 7 cubed or 7 times 7 times 7 here. Once you use up a 7 once, it gets used up first time in all of them. So we're really looking at which one has the most 2's? This one. We need both of those. Which one has the most 3's? The 63. We need both of those. They all have a 7. And so our lowest common multiple, if we multiply this all out, we get 36 times 7, 252. Did someone check this already?
Yep.
That's right? Yep. Okay, good. 252 would be our least common multiple of all of them. If you wanted to use the other technique, you could start listing. So you'd go 28, 56, and keep writing down your multiples of 28. 42, 84, and keep writing them down. 63, okay? But again, if you make an adding mistake on that, you're going to throw things off. And if the number's really, really high, you might be doing it for a very, very long time. This is a little bit quicker. I know the question didn't ask for it, but what is our greatest common factor? It's 7. Do they all 3 have 2's? No. Do all 3 of them have 3's? No. Do all 3 of them have 7's? Yes. And that's the only thing they have for the greatest common factor. That's where we're going to end for today. There is some homework for you to do tonight on page 140.